they vibrate faster and faster until their mutual force of attraction is no longer strong enough to hold them together. This causes them to slip out of their latticework pattern, which therefore falls apart. When the latticework of molecules in a solid has collapsed, we say that the solid has melted. It has changed from a solid state into a liquid state. And now, evaporation and condensation. The trouble with goldfish bowls is that every few days, you have to remember to fill them up with water. Why? Where did all the water go? How did it just vanish like that? Well, why don't you fill the bowl up and dive in so that you can see for yourself what happens. Water is a liquid, so its molecules are moving too fast for their mutual forces of attraction to keep them together in a regular latticework. So they're slipping and sliding all over the place. Although the molecules are packed about as tightly together in a liquid as in a solid, in the liquid state, there is complete disorder and it's every molecule for itself. Some molecules end up being jostled about at the top of the liquid. They, in fact, form the surface of the liquid. Every now and then, this jostling forces an individual molecule to pop out of the liquid altogether, and it escapes into the air. Of course, over time, many millions of molecules escape from the liquid in this way. This continual popping out of molecules is rather like the movement that goes on in a popcorn machine. Only in the case of molecules, most of them stay up in the air and now fly about with complete freedom. No, of course you can't see them now. One of these little lumps on its own is so tiny you couldn't even see it with a microscope. You can only see molecules when billions of them are crammed together in the form of a solid or a liquid. You can see them when they make up the water in your goldfish bowl. But as soon as they escape into the air, they become invisible. But they're still there flying about. Only they don't form a liquid now. They form an invisible gas or vapor. That's why what happened to the water in your goldfish bowl is called evaporation. A change of state took place. The water changed from liquid to gas. It became water vapor. Water is continually evaporating. In fact, if you left your goldfish bowl out in the sun, the water would evaporate even faster, because the warmer the water, the more rapidly the molecules jostle each other, and the more often they pop out into the air. So if you're tired of continually having to top up your goldfish bowl, one solution would be to make the water as cold as possible, so that the molecules will move more slowly, and therefore the water will evaporate more slowly. But now what's happened? Now you can't see your goldfish. How come? Well, as soon as the water vapor molecules in the air come in contact with the cold fish bowl, they become colder as well. And the colder molecules get, the slower they move. And the slower they move, the less they can resist their mutual forces of attraction. So they start to crowd together more and more tightly. In other words, the gas becomes a liquid again. The water changes back from its vapor state into its liquid state. And it's this water which collects all over the surface of your fish bowl. That's what clouds it up. Since the change from vapor to liquid is caused by the arrangement of molecules becoming more and more dense, this change of state from vapor or gas to liquid is called condensation. So when water isn't evaporating, water vapor is condensing. You can't win with goldfish bowls. Have you ever thought of keeping a cat?
All right, so continue. Now this relates to relative humidity. This is on this. Relative humidity, which is the ratio of water vapor in the air to out the air.
And this depends on temperature. The warmer it is, the more it can go. The warmer it is,
Faster, they can keep it up. Think about ping pong paddles. I have a bunch of ping pong balls, and I have ping pong paddles. I gotta keep them up. If I only have a couple ping pong balls, and I have my two ping pong paddles, do I have to move my ping pong paddles very fast? Keep those two little ping pong balls up. It's like bing, 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 bing. But as I keep adding more and more ping pong balls, what happens to the speed I have to go with my paddles? Faster and faster. So this works so with my air. So the faster I move my ping pong paddles, the more little ping pong balls I can hold in the air. Same with my air molecules or the paddles, the ping pong balls are the water molecules. The warmer it is, the more water I can have. And the relative humidity is that ratio. So on a warm day, a low humidity on a warm day might actually have more water in the air than a high humidity on a cold day. But it has to do with how much water could it hold. And this applies to evaporation. Because if the air is saturated or near saturated, saturated means it's holding 100%. We have 100% humidity. The evaporation cannot occur when it's saturated. And the closer you are to saturation, the slower evaporation occurs. That's like if you've ever been to Disney World in Florida in July. It's not nice. You get hot and sweaty, it just doesn't seem to come off you because of that very high humidity. By the way, does it get better when the sun goes down? Like a lot of ways it got worse. Because when the sun went down, the temperature starts to go down, and before maybe we were at 94% humidity. But when the temperature goes down, all of a sudden we're at 100%. Now nothing's coming off you. It's still hot. It's still like 95 degrees. And now you're not even getting a little bit of cooling. It's nice that the sun's not on you. And also, as the air cools, what's going to happen to that extra water? Can it hold it in the air anymore? It starts to condense out onto everything. We have a name for that. Starts with a D, ends in oo. Do. And that's that water that goes on the ground because it condenses out. Geez, when you're in this environment, when's the best time? If you're going to go out and say run, when's the best time to do that? In the morning. Morning, just after the sun comes up. Because as the sun comes up, the air warms up. Does all that water evaporate immediately? No. So you have the air warming up, the humidity goes down, but eventually that water will start to evaporate and it goes back up into the air. You get this cycle. So it's morning. In the Academy, we usually ran in the early morning. We did our PT in the early morning, or when it rained. The humidity might go up to 100% during the rain. The rain is cooling, so when the rain goes actually off of you, it carries that extra heat off you because water is also a good convector. So when that rainwater is actually going there. And in the summertime back east, the rainwater is warm. Of course, you don't do that in Florida because Florida is like lightning, and lightning is the leading cause of accidental death in Florida. So, getting hit by lightning. But let's look at some humidities. Some places. So there's Redwood City. Now, we're actually right now at a high. It's very dry. Notice, what is our humidity right now? 21%. Now, some of you in the back probably can't see that. We're at 21%. That's like about a third of what it was yesterday. The high has set in. It's extremely dry right now. That dry cycle is set in. The high came in. Notice our barometric pressure is 30.36. That's pretty high. On that dew point is 18 degrees. In other words, in order for any water to come out of the atmosphere, you have to get down to 18 degrees on that. It's a day that you really should be consuming a lot of water on that. If we go like Chicago, 24 degrees right now in Chicago. Feels like 24. 53% humidity though. 53% humidity. Feels like 24. Let's check Orlando. Right now it's 78 degrees, 66% humidity. Notice it feels like 81. Now wind will tend to cool things off. Humidity will make it feel hotter. That's why it says feels like. With wind chill and degrees. So this would be like the still air temperature, but because of humidity, it feels like it's 81. Let's see. I was looking at a couple of others. Let's try. Sydney. It's 77 degrees in Sydney. It's 7:58 a.m. in Sydney. 94% humidity right now. 82 degrees. going to be 92 today in Sydney. No, it's summertime in Sydney right now. Summer. It's nighttime there. So it's harder to look. Tokyo has weather much like our East Coast. It's still, let's see, it's 5:59 a.m. It's 39 degrees, but 65% humidity. Let's see. Have I spelled that right? IRO? Well, let's... They don't have Brasilia. Great. What? It's nighttime. I'm trying to think. So Caracas, it's 84 degrees. It's Venezuela. 42% humidity. But it is summer there. On that. So you can see it varies around the world. In Honolulu right now, 64% humidity. Minneapolis. This is Minnesota. It's 11 degrees in Minnesota. 36% humidity. Dew point, -7. Low today is supposed to be -1. Well, we're going to have a heat wave at the end of the week. 33 degrees at the end of the week.
That's a heat wave?
Yeah, it's kind of cold right now. Minneapolis, Minnesota.
What about Toronto?
Toronto. Toronto. Toronto, it's 16 degrees. 16. We're going to have a high of 20, a low of 9. But 83% humidity on that. Okay, we're not, that's it for that. All right, we have one more little thing to do, and then we got to start review. Sublimation. Now, sublimation is solid to gas. It's also applied to gas to liquid. This is a phase change where we go straight from a solid to a gas without first becoming a liquid. The one you are most familiar with is dry ice, which is carbon dioxide, solid carbon dioxide. At normal atmospheric pressure, carbon dioxide goes straight from a solid to a gas, hence the term dry ice, because it never gets wet. But you have to handle dry ice, now it's very easy to get dry ice. Dry ice can be very dangerous when it's very cold. It can cause frostbite very quickly if you handle it. You need special gloves to handle it. That's not very smart. Also putting in sealed containers can cause it, basically you're producing a bomb, because when all that gas expands, it will explode. Basically, force of some explosives. Something to be avoided. Also, if you work with this stuff in a very enclosed room, carbon dioxide will displace the air in the room, so you would suffocate. Yes, sir.
If you're bleeding pretty bad, like say if somebody cut their wrist and you put dry ice on it, will it
Well, it's probably going to freeze it. I mean, I would say I would have other options rather than resorting to dry ice. I mean, compresses would probably be a better option than dry ice, just because you could be doing other damage along the way. That would not be my first thought. Alright, well that's about it for today's notes. So let's get put those away. Sheet of paper, we're going to finish up the Adams video. Adams, part 2. Adams